we're replacing. We're going to solve systems by graphing. We'll pick up the rest tomorrow.
Wait, are we graphing? Do I need graphing paper?
Yes.
Is that on your title?
Yeah. So we're going to do graphing. So just like I said before, if you are watching the video, I apologize. I flubbed up the...
Like and subscribe.
Huh? No, keep what you had. Keep what you had about the definition. Okay. I flubbed up the example. Is what I messed up. All right.
Got a new page.
So that's fine. Here's what we're doing. Look for intersection, and we talked about because when you graph a line, guys, when you graph a line, you are graphing all of the solutions to that one line, right? Every point on that line is a solution to the line. If you plug it in, you get a true statement. So if we have two lines and we find the intersection of the two lines, then that's the one point that makes both equations true. So let's say I have x minus 2y equals 0 and x plus y equals 6. So should have been my first example. I messed up and I apologize. Okay, so looking at these two, what I need is I need the x and the y that makes both equations true. So to do that, I need to graph. Okay, cover up is an easy way to graph this. Do we all agree?
Yes.
All right, because the intercepts are easy to find on here. Here, what's the x-intercept? 0. What's the y-intercept?
0.
Oh, I'm still going to have to find the slope, right? Because that's 1 point. It's going through the origin. Do you see what's happening there? If I do cover up, x equals 0, right? And y equals 0. Well, that's the same point. Those are both going to be 0. So let me just set this up quickly. If my x-intercept is 0, that's the origin. If my y-intercept is 0, that also is the origin. So that's essentially only 1 point instead of 2. So if I look back at that equation, I need at least 2 points. So you can plug another point in or you can find the slope. What you want to do?
Find the slope.
Find the slope. So to find the slope, I need to solve it for
Y.
y. So right now I have x minus 2y equals 0.
No, minus that.
Minus x on both sides.
So it would be negative. No, it'd be 1.
And divide by negative 2. You're exactly right. Because I have a negative divided by a negative, I get
1/2.
one half. So what is the slope of that first line?
1/2.
1/2. Rise 1, run 2, right? All right, so I'm going to go back to my line. It had already started going.
Wait, what about x plus y?
Sorry, I was kind of teasing off.
All right, so what about what?
What about x plus
We'll get to that one. I'm just graphing the first one right now. Up 1 over 2. Here's where you have to be so neat, okay? Because you want your line to be as exact and precise as you can so that you get the correct intersection point. So you might want to use a straight edge of some sort.
Or you can do it goes over 2 boxes. You know what I mean?
Do what?
Like it goes over 2 boxes. It's the corner and there are 2 boxes.
Yeah. All right, for the second equation, that's the one Luke just asked about. What are we gonna do with that one? So that's an easy one also. If I do cover up, where does it cross the x-axis? 6. And where does it cross the y-axis? This is not the same point, however, though. Did you see that? 6 on x and 6 on y are different points. So I'm going to go back to my graph. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 4, 5, and 6.
So it's the same thing as
It's the same thing, exact same thing. That is correct.
Oh my gosh, I got it right.
Okay, so once we get it graphed, and you see why I said you really want graph paper, bless you on this one, because it's hard to see if you don't have graph paper. This point, it looks like 4, 2, but to make sure that that is the correct point, what do I need to do?
Plug it in.
Plug it in. So I'm going to look at both equations, and if this is the correct point, then it should satisfy both of them. X minus 2y should be 0, and x plus y
It's right for the first one. Right for the second one too.
should be 6. 4 minus 2 times 2,
Equals 0.
and guys, 4 plus 2 should be 6. It does check both ways, so yes, that is the solution. Does that make sense? Graph each line, okay? The first one, you see why the first example was a terrible example to start with. It was off the graph every which way, but then yet it crossed at like negative 4, 3. So it was, whew. All right, so your homework. Sometimes you have things, those two lines intersected at one point, right? Easy peasy. That is what we call, and we'll say intersect at one point. That is what we call consistent and independent.
How are we gonna intersect?
How could it intersect differently?
If the line was like this.
Line on top of each other.
Lines on top of each other. So essentially, will somebody grab that? Essentially the same line when you graph, and they could look differently, but you go to graph it and it's the same line. So you probably remember learning this as infinitely many solutions.
Yes.
If they're parallel, they'll never.
That's exactly right. She's already gone.
Look at you.
Infinitely many solutions. We call this consistent and dependent. There's one more scenario. Somebody already said it.
The parallel.
If the lines are parallel lines by definition have the same slope and never intersect, right? The little arrows there indicate that they are parallel. And so this is no solution. They will never touch. There is not one point that will satisfy both equations ever, ever, ever. And so we say there is no solutions and there is no solution. And this is what we call inconsistent. Okay, so 3 scenarios as you graph and solve that you will come across.
Why are we using different words?
Just fancier math, higher level math.